Everyone, it's March 19th. Alright, let's do this. Task scheduler. Maybe another one with the range. They're given an array of CPU tasks, each represented by letters A to Z, and a cooling time, N. Each cycle interval allows the completion of one task. Tasks can be completed in any order, but there's a constraint. Identical tasks must be separated by at least n intervals due to cooling time. Return the minimum number of intervals required to complete all the tasks. So in the first one we have n equals to 2. So after I do an A, I can only do a B. I cannot do 8 again. I have to wait for 2 cycles. Then I can do 8 again. And I can do B, and then I wait and A and B. Idle. After complete A, you must wait for 2 cycles before doing 8 again. Same applies to task B. In the third interval, neither A, B can be done, so you idle. Okay, so we want to, so this one will have 1, 2, 3, 4, 5, 6, 7, 8 cycles. Okay, tasks are uppercase English letters, which is fine. So we can pull out, now use a counter to find how many are there, right? How many tasks are there for each one. And you can always do one. You can always go through every single one, right? Without having to wait. I mean, ideally, you want to hit every one once. We don't want to idle, right? That's basically the thing. You don't want to idle because idle makes you slow. Idle causes time. So you don't want to idle, which means you hit one, you want to hit a different one, want to hit a different one, hit a different one. And okay, so what if we just okay, find the one with the, find the task with the maximum, right? We can sort them based on their sort them based on the tasks, right? We're gonna sort this based on the number of tasks they have. Okay, so we have something with the most task. So we take one from there. Okay, and after we wait for n cycles, right? After we wait for n cycles, we want to hit it again, right? We want to hit it again. So that means for every single one, we are going to, like for the most frequent task, I can put out the ideal, right? The minimum cycles to, like, yeah, the minimum cycles to, let's say, to finish all this 3, well, we have to do 3, and each one has 2. So it'll be 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. That will be 7. That's the minimum required to take care of the first task. And then we try to fit, right, the rest in it. And we can fit because the cooldown is the same, right? So we have some task, right? Some task. So we have the maximum task. We can call it A, and then we have something and A, have something and A, right? That will be the max. And then we have B, and then we try to fit in, because when we fit in this B, it has to happen here as well, right? But maybe B doesn't have as many, so we fit however many B's we need, and then we can fit, C in it, C in it. So basically, each group, right, will contain a task, right, a task and the number, and this will be n, right, a task and n. and then we just try to fit things into it, right? Or try to fit things into it. So what we're gonna have is a, A has like 10, B has 8, C has 5, whatever, right? We sort them, and yeah, we sort them, and then we can create an array, right? We can create an array where we have A at every interval, we get A, okay? And then can put B. And then if that's the case, why don't we just do this, right? A, B, C. We go through everything, and now we hit through everything, and whenever something we cannot do anymore, we delete it. We just hit the next one. What do you think about that? Yeah, because everyone has the same, right? Everyone has the same cooldown. So yeah, this is not that bad. It's not that bad. So we do have to hit every single one, and then we have to start again. And if one of them can't start again, so I'm actually thinking, do we even need to sort it? Right? Do we even need to sort it? So for example, in this second case, right, we have A is 2, right? A is 2, B is 2, C is 1, D is 1. Like if I don't even sort it, I will go and then n equal to 1. So the cycle is 2. So I go A, B, right? Because I have 2, and I go A, B, and then I go C, D, right? I feel like we don't even need to, because it's gonna be in this group of n plus 1, right? It has to happen, a group of n plus 1. There's just no question. It's a group of n plus 1, and you fit something in it, right? And if you don't have enough to fit, you don't have enough to fit, and then you have to start again, right? Have to start again, and it doesn't really matter. Interesting. Like in this case, I can say A is 3, B is 3, right? N is 3, so the cycle is 4. So I have to do AB, wait, AB, wait, and AB. Don't wait again. So that's 8, 9, 10, right? That's 8, 9, 10. Okay, an interesting way to check is if we go CD first. I mean, in this case, CD first, it will work as well. I'm just thinking we probably don't even need to, right? We don't even need to. I just hit every single one. Because it's 26 letters, so I hit every single one. And then once I hit, I go back. I'll hit it again, and I go back. So every time, every round, I will go from the start and then just pick things to fit into the current window, right? We just pick things to put in the current window, and until at the end, right? Until at the end. Okay, we can try this. I feel like it should be right. I feel it should be right. Okay, let's do this. Okay. Yeah, I just... Oh, hold on. There we go. It's like something is wrong. Okay, let's do this. We're gonna go here. What is this? That's what I'm trying to do JShell stuff. Oh, there we go. All right, so we're gonna do counter is equal to new int 26, right? And we know counted, yeah, for char c of tasks, okay? Then we can say counter c minus, I think it's 65, right? Plus. Yeah, I think it's 65. There's a capitalized A. So now we have the counter, right? And then what we need to do is to go through the whole thing, go through the counter. How many times do we have to go through? Oh, I have the total number of tasks. Okay, so int total is tasks.length, right? And we say while, I don't know, total is larger than 0. Okay, then we just go through this, and then we'll put at most n into it, right? We put at most n into it. So we go through and we try to see if we can get n. So we go through and what do we say? We have the current round. So current equal to n. Okay, while current, we just go through this. Okay, we can say int current is equal to n. So while current is larger than 0, actually no, I'd like to go for int I equal to 0, I smaller than 26, I plus, okay. If counter I is larger than 0, okay, if counter I is larger than 0, then counter I minus and total current minus, right? And we say if current is equal to 0, that will break. Yeah, so we go through the whole thing, right? We go through the whole thing, and then once we hit it done, and then we can have interest equal to 0, right? After we hit one round, depends on if total, right? Depends on the total. You can say, but actually depends on the current, right? Depends on the current, because current might not be, but if I went through the entire thing, yeah, if I went through the entire thing and current is still not turned to 0, and it depends, right? It depends on the total, right? It depends on the total. So what I need is, because at most each time I can reduce by n, right? That's at most each time. And current minus, and also total minus as well, right? So at the end, how many time points we need to add? Well, there are situations where we hit everything, then depends on the total, right? If total is still larger than 0, right, we say if total is still larger than 0. Now in that case, because total is still larger than 0, we haven't hit everything, so we have to add. Rest has to add equal to n, right? But else, if total is not, right? If total is equal to 0, right? If total is equal to 0, Now that's a different situation. If total is equal to 0, then we have already hit everything. And then rest shall add plus equal to current, n minus current, right? So current basically is how many we have taken away in the last, right? So if n is 5 and I add a current, take 2 and 3, so I'm only willing to do that much. And yeah, and I will return rest. Okay, let's take a look. Yeah, this is right. Nope. Okay, first one is wrong. Everything is wrong. I'm short by 2 in the first one. Interesting. Hold on. So what we have is at the beginning we have. Okay, let's make sure that ask table is right. Capitalized letter A is 65. That is correct. So that's not the issue. So we have the counter. We have the total, which is the task length. And the rest is 0. Well, total logic is 0. And equal to 2. And I go through the whole thing. If it's larger than 0, I minus minus. And a current minus minus, total minus minus. Okay, now I go for the second one. Minus and minus minus. And now current equal to 0. Now we break out. Okay, total is larger than 0. And the rest will plus equal to 2. Oh, it's not 2. Damn it. It's plus equal to n plus 1. That's the total window. The total window is n plus 1. Okay. And plus 1 is the total window. And what if n plus 1 is the total window? And if total is equal to 0, what do we do? If total is equal to 0, that means we hit everything, right? If we hit everything, then however many that we handled in this round, right? Current shall equal to n plus 1, I think. Right. Current shall equal to n plus 1. Current is n plus 1 because that's the total number I can allow to be taken off, right? And then minus 1, minus 1, minus 1. And then once current equal to 0, I exhaust this entire thing, okay? And I can just do, in that case, then it doesn't matter. I can just say rest plus equal to n minus current. That is not right. No. This n plus 1 minus current. Okay, let's try this. All right, this one looks okay. And 621. Each round of execution has a window size n plus 1. We want to fit as many different tasks as possible in this window. Right? If there are not enough unique tasks to fit n plus 1 to fit a window, the remaining time slot will be idle. Right, we keep this pattern going until all the tasks are completed. Completed, yeah. I think this is ON. I can say 26, and let's hope this was right. Okay, we have some. Yeah, I just submit it. See if it passes. Oh, damn it! I did it last time, but I failed this time. Jesus, man. Output 13, expected 12. Maybe we do have to sort. Damn, that didn't sort. All right, so we have A3, B3, C3, D2, E1. All right, so I have 2, so it'll be 3, right? So I'll be AB3, ABC, 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 and then D, E, empty, and then D, empty, empty. Right, and of course we don't count these two. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But expected is 12. Gordy, that's not right. You put a D here, you put a C here. Good man. Okay, so the problem is we need to miss a match. Interesting. How? Okay, this one does not work. Actually, this doesn't work. You cannot put D here, right? Because D and D requires. Hold a second. Hold a second. Let me Control Z this one. Okay. So this is what we have, and that costs us 13. So what we want is to put this D somewhere like here, right? We'll put D here. And so this one we don't need, and then we put A here. What do you say? I say we shall do A, B, C, D, E, and A, B, C, right? Like something like this. We loop around. We loop around when we have more. Instead of just going through this, we loop around. Well, the benefit of this is because we hit 3, and if we keep going, right? We keep going. Then in the next round, whatever the before, we can still do it. We can hit it, right? And then we can keep going, B, C, and then we have a D again, but we don't have an E, but this one's also done. Then we can do A again, and then we can do B and C. Then we hit it, done. How would you program this? So you want to spread them out, right? That's the idea. You want to spread them out. So we just go through Yeah, we'll try to see if we can fit. But if we cannot fit, then there's no other way, right? If we cannot fit, that's the only way. You just run this, right? But if we can, we just keep moving forward. Right, you start from something and then you go, and you go through the whole thing, okay? You go through the whole thing until n is hit. If n is not hit, yeah, you go through, n is hit, and you start from wherever you are, and just keep moving forward. And for the next round, if you go through the whole thing and n is, you don't have enough, right? You don't have enough. You go the next round, you're starting from here, and you go, and you have n, and you keep moving forward, and you loop back, right? You loop back. You loop back. Okay, loop back, yeah, you can. Because, you loop back. Yeah, because if you go through the order, right, you start from A, and then you blah, 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 and then you keep going, and then you loop back. That is fine, right? That is fine for the current n, right? You hit current n, and then you keep going. Unless the n is not too big, right? Unless the n is not too big. Would it be possible that when you loop back, it, like, it is possible. It is possible, right? You end with whatever, and the next round come up. This is, yeah, like the distance is not good. Yeah, it's totally possible. Yeah, everything is once. You hit them once. Huh. So that's why you want to sort it. That's why you want to sort it. Right? You want to sort it. Yeah, you want to sort it based on the count. So now you go from the highest going down, right? The highest. So because it's the highest, it's just guaranteed that the next time and you loop, I think next time you loop. So you go from the highest count, okay, and then you go, and then you keep going. And because the highest count is always at the top, so when you hit the highest count again, it's always going to be enough difference, okay? Then you hit the highest count, and then keep going, right? And then next one you hit, that might not be, yeah, that might not be right. How come I was able to solve it last time, but not able to do it this time? Damn. All right, if n is larger than the number of unique tasks, then I think it's pretty straightforward. Whatever we have, this should be the answer. But if n is smaller than the number of tasks, that is when things are a little bit tricky, right? When n is when n is smaller than, we can say we just go through the whole thing until n becomes larger than again. That is an idea. That is an idea, right? So basically what we're saying is we go fit everybody once, and then after fit once, we check again, right? Every time we check to see if it's still everybody, right? We see if it's still everybody, still larger than n. If it is still larger than n, we just keep going forward. Yeah, the ideal is, because if we have more unique numbers than n, and after I finish the first, then we'll do the second. It doesn't seem to be the right way though. Or if we go with smaller count first. I have a small count with some value with a small count. Okay, so small. And then we find another value with a small count. So what's the theory here? For smaller count, we can say the big count. Can't really say that way, right? I mean, if we do smaller count first, I'll do, E, D, C. And then E is gone, that'll be D, C, B. Right, and then, oh, you can't even do C, because it has to have 2. Ooh, that's... Or maybe we just skip. Maybe we just skip, right? So we do EDC, and we keep track of what's the last time index happens, right? And then, like this. We keep track of their indices. What's the last time they were there? Because all we need to do is just to fit as many as possible, right? So we do A, B, C, and then we track their index, right? This is 0, 1, 2, and then we say D, E. Okay, so D, E, never hit before, and then yeah, we can do like minus 1,000. Right, it'll be fine. And then next we're done, right? So we go, we're back to A. And A now is 3, 4, position 5. We check, it's good. Because 5 minus, we have 5 position, or 5 minus is minus 1, so I have 4 positions. So we can do A. Next we do B. That's also good. Next we do C, which is good. Next we do D, which is good. And we don't have E. So we go back to the A. Now there's 9. 9 minus 5 minus 1 has 3 difference. 3 idles. That's also good. Now we do B, then we do C. Right? That actually looks even simpler. Okay, so now we don't even need a counter. I just need pre-index, right? Pre-index. We'll fill this with minus 1,000. Doesn't matter, does not matter. And then we just go through the whole thing. And interesting. We go through a whole task. No, I do think we still need counter. So I don't have to go through the task all the time. So I still need counter. Okay, let's still do counter. All right. So we have counter new int 26. Let's still do that. And now we get this. And we get this total. And we have res. That's fine. And then what we need to do is total, and then we have an index. Index equals to 0. Okay. So this, and we say if counter index is larger than 0, and so we have kind of 2 index. We have an index to loop through, and we need another index to keep track of where we are, right? To keep track of where we are. It's basically okay. So we don't need res, honestly. We're gonna have an I is here. Okay, we're gonna have a j is here, right? So we say if this is j, if this is larger than 0, and I minus pre-index j is minus 1, okay, is larger or equal to n, right? Which means this is larger than n, right? If that is the case, then basically I can say I can take j, right? Then we do counter j minus minus, right? Counter j or minus minus, and then total minus minus, and then pre-index j will equal to the current I, right? Because I'm putting myself at the current I, so the pre-index j will equal to current I. And then after that, I will, that's it, right? If that's the case, then we do it, right? And then and then I always plus plus. Okay, I plus plus, and does J move forward? J does, right? J move forward as well. J move forward as well for each one. So if this one doesn't work, well, hold a second. Does J move forward though? You shall be going through all the J's possible, right? I think you should go through all the J possible. Whatever the J is, you should just go through them. Go through the whole thing, right? You should go through the whole thing. Because if you find something that's not possible, yeah, if it's not possible, then you will idle. Right? What if the current J, it cannot work, right? Alright, we do this. Alright, we do this. And then we're back here, but it doesn't work. So we idle, and then we idle. So saying we keep idling until I don't think we should keep idling. I think we should keep checking to see if there is any, like the I doesn't change, right? Because it's pointing to the current one. I doesn't change. And then the J can move forward, right? J can move forward. So when we idle is if there's not a single J that works, then we idle, right? So I can just go through the 26 thing. Okay, we'll go through 26. We still keep the J, right? We go through them, and then if everything's good, or just good, then we'll just keep moving forward, keep moving forward, keep moving forward. But once we hit something that's not good, but I'll still keep trying. Right, so we go through the whole thing, and it's no good. Why is it so hard? Yeah, J just move forward, right? J move forward until we hear something that, it doesn't work. I think if we hear something that does not work, or J is equal to 0, So you're saying we just go through the whole thing, okay? We go through the whole thing, and what is I again? Yeah, I increment I. I'll go through the whole thing. As long as it's good, we just keep moving forward. Right, we keep moving forward, so we go through the whole thing. And then back again. Right, and then we go through the whole thing. And if nobody can move, okay, so we'll go through the whole thing and then just, you know, if it hits, then move forward. If nothing's good, so by the end we will say, where do we get stuck, right? Where do we get stuck? Okay, and then so we'll go through a round, and it's only when we go through a round where we cannot progress, that's when we will increment the result. That's when we'll increment the result, increment I. So we'll go through this and then see if we, as long as we progress, right? Because every time we progress, the I will increment. So as long as we progress, we should just keep going. But if we don't progress, then we don't. Okay, so what you're saying is, instead of doing this way, what we'll say is for, int j is equal to 0, j is smaller than 26, j plus plus, right? We'll go through the whole thing. Oh my goodness. Right, so we'll go through this and encounter j larger than 0 and I minus this total, this, and then I plus plus, right? So every time we do this, I move on to the next one, and now we try it again, so we'll go through the whole thing, right? We'll go through the whole round, and what we need to check here is have a Boolean value, right? We call it, what do we call it? We call it the progress, has progress, okay? So as we false, but every time we do this, has progress, set it to true. So once we handle this, okay, we say if total is larger than 0, okay, if total is larger than 0 and not has progress, we do not have progress, that's when we increment this. So this is the idle, right? This is idle time, because we go through the whole thing but we don't have any progress. Now we have the idle, right? And then we go back up and try it again, right? We try it again. But as long as we have progress, then we should just go up and then try it again and try it again. Okay, so if that is the case, right, that is the case until at a certain point total is right, if this blah blah, if it's larger than 0, so we have to say if, right, if total is equal to 0, then we shall break this, right? If total equals 0, we shall break this, and then we'll get out. And we don't need this. Okay, wanna give this a shot? Yeah, let's give this a shot. I mean, it's actually using a very different method. All right, let's first check. And they're correct. What the hell? Huh? Oh, there's no res. My bad. I think it's I. Interesting. I. That's the first tick, right? I tick forward. Yeah, maybe. Just take a look. If it's I, maybe it's I plus 1. Okay, this looks good. So change the idea, right? So the idea now is just filling as many different, right? As many different tasks as possible, right? If no more tasks can be scheduled, we increment the time by adding idle. All right. We'll see how it goes. Hopefully it's not too slow. I feel this should be right. Oh my god. This is terrible. Man, I'm definitely in a very bad shape today. Holy crap. This is terrible. Oh my god. Yeah, this is not working on this one, huh? How? That was a 1. So output 16. Jesus. This is not good. This is not good at all. All right, A is 2, 3, 4, 5, 6. So I have 6 A's, right? 2, 3, 4, 5, 6. We have 1B, 1C, 1D, 1E, 1F, and 1G. So the current idea is you will just do A, right? And it's larger than N. N is 1. So we'll fit A. And then it goes through the whole thing. And then we do B. Can we do B? Yeah, we can do B. Because it starts is minus 1000, so we can do B. Then we can do C, so we can do a whole thing. 2, 3, 4, 5, 6, 7. So we can do everything. And then the rest will all be 0, so we don't do. Okay? And then we still have a bunch of A left. Right? We have a bunch of A left. We have a bunch of A left. Oh, yeah. Because if you do A, B, C, D, E, F, G, then you do A, you have to do this. I see. Yeah, this is not good. It should be A, B, A, C, A, D, or something like that. Damn it. I'm royally stuck on this one. It's not supposed to be that hard, man. Next available. So at the start, everybody is 0. Okay. It doesn't matter, whichever one pop out. When I do it, I'll put it so it will be in a queue. The next smallest gets out. Right? And then the next one. So the priority queue, what if we say first check on the time, when is it allowed, right? So we have a time point, we have a timestamp. Okay, so if the timestamp is the same, I say we get, if the timestamp is the same, we get the one with the highest count. Is there any reason for that? If the timestamp is the same, then we get the highest count out. Well, the reason for that is if we have two tasks, the timestamp is the same, and which means they either can get out. But if we use the one with a smaller count, then we have one with a larger count left, which increase the chance of idling. All right, priority queue. Okay, I'll change the idea one more time. Priority queue. Damn it, Java. I never remember this priority queue. How do I do this? Priority queue, you will write a comparator. Okay. String length comparator. All right, we just write a comparator then. Okay, that's fine. So what do we do? So we do the counter first. I do need a counter. Okay, so I don't need this, don't need this. I do need a counter. And I think I don't need any of this, so I delete all of them. and I need a priority queue. So we say priority queue int, okay, pq equal to new priority queue. Okay, so now here we have to have something here, which is the capacity. Now capacity is 26. Then we need a comparator. So we write it here. Okay, so basically we'll copy paste this thing. Okay. All right, so this is not string comparator. This is going to be custom comparator. So implement, this is going to be int, okay? And compare is not string, it's going to be int. We call element. I'll just call it x and y, that's fine. X. Right, and then this is gonna be y. Okay, so we say if length, so x shall equal to the first element is going to be the next available position, and then there's an count. Okay. All right. So if x0 is equal to y0, okay, then return integer dot compare x y1 x1, right? So a larger count goes first. Otherwise, we say return integer compare x0 y0. Okay. Smaller position goes first. Okay. So here this should be custom comparator. All right. So now we have this. Now we need to add every single thing into it. Okay. So we say for let's say int I 0i smaller than 26 I plus plus. Okay. If counter I is larger than 0. Oh, holy crap, I need I as well. So we need a first available position count and letter task index. Okay, but this one task index, we don't really have to worry about it. So if this is larger than 0, then we say pq dot add new int. So the first available is 0, and then this is the count, and we also have I. Okay, so we go through this. Now we have our priority queue, and then we just go through the priority queue while, right, pq dot is empty if pq is not empty. And then, we also need int res equal to 0. And we all pop current. We say int element equal to pq dot pop. I think it's called poll. It's not called pop, right? So we basically pop it out, and we will check, right? We have a count. Where a current count element is the current count, element 0 is the position, and then we should say element 1 is the count, okay, minus minus, and rest plus plus, right, because we add the current time point, element plus plus, and we say if element 1 is still larger than 0, okay, which means we still have more to go, then we say element 0, okay, shall equal to, oh, do we even need a task index? I don't think we need a task index. We don't need a task index. That is not necessary. So task index is not necessary. All right, then we just say this shall plus equal to n, right? So if it was a 0, then the next one should be n. Like if it's 2, 0, 1, 2, actually no, because we have n in between, so actually should be n plus 1, right? If this larger than 0, we do this, and we say pq.add element again. We put it back in. Otherwise, if this is equal to 0, right, then we don't do it. And at the end, we'll return res. All right. Let's see. This is the third method that we try. Oh, I was in very bad shape today. Very, very bad shape. I don't really think this is a hard problem, but for whatever reason, it's just... Oh, no. I don't know. For whatever reason, I've just been struggling. Marvelously struggling. Typo. Is this one right? Oh. Huh? Cannot find symbol. Wait, I was following this. Oh gosh, shoot. All right, that was my fault. It was syntax error. So okay, so this be custom, and I probably should call this new custom comparator. Wait, is that right? That's defined on the outside. Oh, there gotta be an easier way to do this. Now there gotta be an easy way to do this. I think I'm doing this. Hold on. Maybe a comparator dot comparing, right? Key extractor. No, I do have to. Is there another way? Oh, I can do this. Look at that. Okay. I think we can do it easier. We can just say x, y. Okay, then we do delete this, put it here. Then we delete all this. How do you like that? Sound good? No. Damn. I think it's because, oh, I need a tick. I need a tick. I didn't do the tick. I see. Hold on. While PQ dot peak 0 is larger than res plus plus. How about this? Yes, that's the one. God Lord, this one shall be right. I don't know, just very bad shape. Use priority queue. And each element in the queue is next available position and count. Right. We always pop the task with the earliest next available position. Nah, we should next available time. Right. Not position, it's time. If several tasks have the same next available time, we pick the one with the highest count. This is because if we exhaust the low count task first, then we increase the chance of idling with only the high count tasks left. I don't know what's the runtime for this. Whatever the runtime is for this. Log in, how many times you have to run? All right, come on, give me. It's in an hour and 14 minutes. Jesus. All right, it was bad. It was very, very bad. All right, I don't want to look at it again. I don't. I will take a look tomorrow. All right, I'll end it right now. I'll see you guys tomorrow.